Okay, so let's wrap up this chapter with section 3.4, solving problems using acute triangles. So in this lesson, they're just going to give you problems, and you're going to have to use your tools. Your tools, as they've listed here in the Keep in Mind section. Your tools are the sine law, the cosine law, and the primary trig ratios. And then it says, and the sum of the angles in a triangle may all be useful for solving acute triangle problems. These are your tools. So remember your sine law, that's A over the sine of A, equals B over the sine of B, equals C over the sine of C. Or change the letters depending on what the triangle is. Remember, this is all about having sets. Cos law. Again, set it up for the letters you need, but A squared equals B squared plus C squared minus 2BC cos of A, and this is about a contained angle. And primary trig ratios, that's SOHCAHTOA. That's sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So these are your tools, as well as all triangles add up to 180 degrees. When selecting the sine law or the cosine law, consider which sides and or angles are given and which side or angle to be determined. So you can use the sine law if you find that you have a set and you need something else. You can use the cosine law if you have a contained angle. You can use the trig ratios only when you have 90-degree triangles. So you don't need 90-degree triangles for the sine and cosine law. However, you could use them a little bit complicated, though, because in 90-degree angle triangles, just use the trig ratios. So there's only one example here in your notes, and it says determine the height of AC to the nearest meter. So in this diagram here, it wants you to find AC. It wants you to find this length here. And the problem with finding that length there is that you only, in this triangle ACB, you only have this 90-degree angle and you have this 66 angle. It's sharing a side, though, with triangle CDB. Triangle CDB has these two angles and this side length, and then they share this side. So sometimes a good strategy is to separate the triangles to see if you can solve them by themselves. So let's start with this triangle. I know it's not going to be exactly like it is in the picture, but I'm going to use my triangle tool to help me. So that's the bottom triangle, and we'll get a right angle triangle going for the other. Okay, we'll label them. So this guy is C, D, B. That's this triangle here. This guy here is A, C, B. We know that this is 66. We know this is a right angle. We know this is 55. DB is 50. And this is 45. So remember, I'm trying to find this. This is the side I'm trying to find. Well, I can't use my trig ratios because all I know is this is 66, this is 90. I could figure out that this is 24. Oops, let's get a pen. I know that this angle here is 24 degrees, but that doesn't help me to find this side length. But remember that in my picture, there was a shared side. This CB. This CB is exactly the same as this CB. So in this triangle, if I find this CB, I could use it in this triangle. And so when I look at this triangle down here, I can use the sine law or I can use the cosine law. I could not use trig ratios in this triangle down here because it's not a 90-degree angle. Well, it might be. I haven't checked what this is yet. So let's start with this angle up here. This angle C up here is 180 minus 45 minus 55. It's whatever's left over. 45 and 55 make 100, so it's not a 90-degree angle. It's an 80-degree angle. Okay, so I can't use SOHCAHTOA. However, now look what I have. I have a set. Once I have a set, I can use the sine law. So this set can help me get this side here because it's opposite from 45. So down here I can say 50 sine 80 equals, I'm going to call it CB, but I could call it small d, CB over sine of 45. So I have CB sine 80 is the same as 50 sine 45. Cross multiply. So CB sine 80 equals 50 sine 45. CB is what I want to find, so sine of 80 has to go. So divide both sides by the sine of 80. That cancels, leaving me CB. CB is 50 times the sine of 45 divided by the sine of 80. I'm just going to use the calculator here on my desk. So 50 sine 45, press enter in between, divided by the sine of 80. I get 35.90. 35.90. Now, I don't get exactly 35.9. I've got some decimals sitting on my calculator, which I'm going to keep because I want to use them in my calculation up here. But I can, now that I know that this is 35.9, I can transfer that here. And now I have that. This is what I want to find AC. I have a 90-degree angle, so I'm going to use a trig ratio. This is my reference angle. It's the one I was given, and so it's the one I want to use. And based on that angle, I could call this opposite. This 35.9 that I just calculated is adjacent. So back to SOHCAHTOA. If I have opposite and adjacent, that's tan. I could say that the tan 66 equals opposite over adjacent. Now remember what I told you, 35.9 wasn't exact. It was 35.90075, on and on. However, even though I'm writing 35.9, it's sitting on my calculator. I'm going to cross multiply here. So I have AC times 1, which is AC, equals 35.9 tan 66. Use that 35.9 with the decimals sitting on your calculator, and then just go ahead and multiply it by the tan of 66. And to the nearest meter, I get 80.63. To the nearest meter, I would say AC is 81. I should say meters, 81 meters. Done. Here's my answer. Okay, so this lesson a little bit more difficult, and what makes it more difficult is the questions that are in your booklet don't always include a picture. So it's going to be important that you are able to draw the pictures, and sometimes that can be difficult. So if you are struggling with the pictures, please come to me and I can help you draw those pictures, and then hopefully with the sine law, cosine law, and the primary trig ratios, you're able to solve the problems. Good luck.